All right, we're going to get into chapter six now, and a couple terminologies to get us going here. One is a monomial. That means where there's just one term. And a polynomial means that we have some difference of monomials. So there's a bunch of different terms that we have, or potentially could have. Here's some examples of things that are polynomials and ones that are not. Looking at the ones that are not, anytime we have an x in the exponent, absolute value, if we have uh, a variable with in the denominator, fractional exponents, those types of things, those things that are not. Everything else that you see up there kind of is a polynomial. So the degree of a monomial is the sum of the exponents of the variables, just the variables. Okay, so as we look at the monomials here, the degree, well, this one, of course, would just be 6. All right. The the degree here on letter C, that's actually x to the first. So if we add those, the degree there is going to be 4. D, I'm going to get back to B in just a second. D, we have 2 and 1 and 3. Well, so that degree is going to be 6. So the question on B is, what's the degree of that? Well, remember, the definition is it's the sum of the exponents of the variables. Well, there aren't any variables. So anytime we have a constant, the degree of that monomial is going to be 0. Okay, so we have those. All right, now the degree of a polynomial is the highest powered exponent that we have. And so one of the things that we do to help us out identify these things is to make sure that we always write it in what's called standard polynomial form. And that starts with the highest powered exponent first, and we go in descending order until we get to the constant. So an example of that would be like down below here. Okay, so some things that we're going to look at when we identify things is our leading coefficient. That's the number that leads the way. That's 5. The degree is going to be the highest powered exponent. That's going to be 3. We'll ask things like the number of terms, 1, 2, 3, 4. Yeah, 4 number of terms. We call this a cubic, is what we would call that. We always name the polynomial by its highest powered exponent. Okay, and so here's a list of the different ones that we would see. We have constant, linear, quadratic, cubic, quartic, quintic. Typically don't go any higher than that. I mean, we can, but we'll keep it down there. And if it has 2 terms, we call it a binomial. If it's 3 terms, it's a trinomial, and so on and so forth. So let's do this. Here's some good quiz questions. Let's write it in standard polynomial form. So in letter A, we'd start with the highest powered exponent, keep the negative with it, negative 5x squared plus 4x plus 3. Now, it wants us to find the leading coefficient. So I'll just say LC here. That's going to be negative 5. What's the degree? The degree is the highest powered exponent. It's a 2. Sorry about that. A number of terms, obviously, is 3, and the polynomial, since it's by 2, would be a quadratic. All right, let's do the same thing for B. Let's write it in standard polynomial form. 8x to the 4th plus 3x squared minus 4. All right, so again, our leading coefficient is going to be 8. The degree is going to be 4. Number of terms, we do have 3. And so the polynomial would be to its 4th power, so it would be a quartic trinomial is what we could call that if we're getting real picky, but usually name it by the degree. All right, so there we go. Now to add and subtract polynomials, just combine like terms. So I always go with the highest powered exponents first. And what we're looking for here is those. So let's add those. So we get a 3x to the 3rd. Let's see. Well, nothing to add here. So we're just going to put the 5x squared next. And always put them in order. We can take the negative x and the 7x to get a 6x. And then we have a positive 9 and a positive 4 for a positive 13. And by doing that, we're already in standard polynomial form, which is exactly what we want to do. Just it helps kind of make sure to go through so you don't forget anything as you mark those off. Okay. Now, once again, back in the day, we kind of talked about subtraction, being a little smart with this. And I think what I like to do is I like to distribute that. And so basically just change the sign of everything that you have there. So you have a negative x squared minus 6 and a plus x. There we go. Sorry, plus. Let's go with that. All right, so if we combine our like terms, we'd have negative 3x squared. That's those two added together. Nothing to add to the x, so we're just going to go plus x. And then we can add the 3 and the negative 6 and get a negative 3 is what we can do there. Always helps to, instead of subtraction, change it into addition problem. That's, in my experience, has been best preventer of problems. Okay. All right, now sometimes what we want to do is be able to graph some things so we get a picture of what's going on, and then we can identify what the zeros are. All right. So as we kind of take a look at this case, I've kind of given the screenshots of the calculator here so we can kind of see that. But if we describe the graph, well, if we describe A, it's a cubic. Obviously, going from left to right, it is increasing. And then if we want to identify the number of real zeros, we're really just looking at, well, how many different spots does it cross the x-axis? Looks like one, two, three. Okay, so three real zeros. And any coincidence that that's the degree? I don't think so. There's no coincidence there. All right. So B, what describe this graph? Well, it kind of looks like an M, doesn't it? It's a quartic. And if we kind of take a look here, it kind of starts up, it goes up, and ends down. So both ends kind of go downward. And the number of real zeros that we have again are one, two, three, four. Looks like we have four real zeros, which again shouldn't be any coincidence, as that's kind of the degree. That'll tell us the most number. It doesn't mean that's what we'll get. That's the most number of zeros that we'll get. And we'll talk more about that as we go on with that. All right. So once again, let's graph these and see what happens here. Yeah, we've looked here, again, finding those real zeros again. We did see that we had one, two, three. We had three here. All right, so we see that pattern. Just when we start recognizing the pattern, we think, oh, there's going to be two real zeros. But remember, with parabolas, we could have one. And in this case, we don't have any. So there's no real zeros that we have in that case. So it's always a good idea to graph that out to get a picture of what it's looking at. So I love that graph for letter A. That's my favorite. That's the cubic, the oh no you didn't girlfriend graph. I love that one. B, again, you got to be careful, graph those out, and we're all set there. So that would be the assignment if we had a book assignment, but we don't. We're on Moodle. So go there, do section 6.1 and enjoy. It should be a good assignment.